Okay, so, all right, I'm gonna go ahead and go over transforming graphs of sine and cosine for you. If you have a function and it's like y equals 3 cosine of x, I'm gonna specify what's inside and outside because that is important. If we have a function like this, how do we know how do we know exactly how this is different from, let's say, y equals cosine of x? Right? So why are these two different and how can we tell? So there's four main things, and that's what this worksheet is going over for trig functions and graphing them. There's amplitude, vertical shift, period, and horizontal shift. And one of these things, the period, is mostly unique to sine and cosine. It's going to be in terms of pi. Usually, you're not going to be working with anything that's not in terms of pi. So your period's going to be in terms of pi, and that's something that you haven't done before outside of sine and cosine. But the amplitude, vertical shift, and horizontal shift, even though they seem kind of weird and different, they're actually no different from the things that you've done before. So let's go ahead and take a look at the vertical and horizontal shifts. So it's the same thing if you look at y equals 3 cosine, I'm writing this twice, I don't know why, x plus 2. So actually, I'm going to modify this a little bit. Let's just say y equals cosine of x plus 4 plus 2. Okay, so if we have this right here, okay, this really is not any different in terms of what the plus 4 and the plus 2 means than if we had, let's say, y equals square root of x plus 4 plus 2. Okay, so if we have this, right, and let me just make that clear that the plus 2 is not inside of the square root. So if we have this, right, and I'm sure you've already worked with graphs of like this before. So if we have this and we're graphing y equals the square root of x plus 4 plus 2, let me go ahead and just graph that in the calculator. I don't know if the camera focus can get it, but we'll see. Y equals square root of x. Okay. Oh, yeah. Okay. I just remember what it was. So y equals square root of x is a graph that looks like this, right? It goes like, whoop. That's how the graph goes. And so that's how the graph goes for y equals square root of x. And we are adding a plus 4 and a plus 2 to it. Now, if we have something, same rules still apply, if we have something that's inside of the square root, if it is inside, it is separated from the x, it is separated from the stuff on the outside, it's with the x, right? X plus 4, that's going to be affecting our x-axis, right? So plus 4, and if it's inside, we always reverse it. That's just a rule. I'm not going to prove that, but that's just a rule that happens when if it's outside, you don't reverse it. If it's inside, you do. So we're going to be shifting the x minus 4. So let me go ahead and say 1, 2, 3, 4. Right? This is the normal graph of this, right? And if I just had the graph y equals square root of x plus 4, we would, since it's on the inside, we do the opposite and we go back 4. So this is negative 4 right here, right? So now this is our graph. I'm going to erase the other one. So now this is our graph of y equals square root of x plus 4. It's going back 4 spots. Now let's say that we have the graph of y equals square root of x plus 2, right? This is on the outside, meaning that it's going to be affecting our y-axis. So, well, again, this is our normal y equals square root of x. We're going to go up 1, 2, right? We're going to add 2 to the y-axis because it's on the outside, it's affecting the y, and therefore the graph's going to look like this. So you see before we went back 1, 2, 3, 4 because the 4 was on the inside, and we went up 2. So if we combine all of this, right, and we bring back down our original problem here where we have we are graphing y equals square root of x plus 4 plus 2. That plus 2 is on the outside. We would graph it as, all right, well, it's just square root of x, so it's just a graph like this, but we've got some transformations to it. So what are we going to do? Well, let's look on the inside. It's plus 4. That means we're going, looking at the x-axis, we're moving 4, but because we reverse it, it's plus 4. We're going to be going minus 4. That's how it is. 1, 2, 3, 4. Minus 4, right? We're going to be going back 4. However, we've also got stuff on the outside, so we're also going to be going up 2. Because the outside affects the y, and it's normal, it's not reversed, so we just go up 2. So we go up 2. And then if we kind of, see where these guys line up, those are the two transformations. And after we've accounted for these, all this is a graph of y equals square root of x. Boom. There we go. Same as before, same thing. Now, this translates well into the cosine, because it's the same thing, right? Our graph of cosine is just this. Hopefully I don't mess it up. It's got this guy. I'm just gonna go, it goes up, then goes down, then goes like that. Okay, this is our graph of cosine, right? And this is our graph of cosine. Let's gonna say this is pi over, we'll just, I won't even mark those. This is our graph of cosine, right? So if this is our normal graph of cosine, and we have y equals cosine of x plus 4, this is affecting our x-axis in the same way. It goes the opposite. So we're going to go ahead and go back 4. We're going to go back 1, 2, 3, 4, negative 4. And this is where our cosine is going to start. Remember, sine starts up here. It starts on the line. And cosine starts up at the top. So like sine is like this. You start in the middle, and then you go, I think that's how you do it. Yeah, that's how sine is. But cosine is like this. Right? Same thing, but just it starts in a different place. So we start up at the top because it's cosine, and then we just go down, and then back up, and then down. Whatever. It's being transformed back 4 because that's on the inside. Right? Now if we do plus 2, let's say we have y equals cosine of x plus 2. I just want to make sure you know that the plus 2 is outside. So y equals cosine of x plus 2. Now it's the same thing, but we're just going up 2. So 1, 2, we go up 2, and we're going up 2. It's kind of difficult with cosine because you're not starting at the 2, but you're kind of going up. So when it goes down, that's the 2, and then we just go down like that, and then it just kind of keeps going like that. I'm not super great at drawing cosines. That's how it is. And as opposed to a normal cosine, which would just be 2 lower, the normal cosine would just be like this. Right, so that's the normal cosine. That's our modified cosine. We're going up 2. That's how it is. So if we were to do cosine, y equals cosine of 3x plus 2. Oh, no, sorry, my bad. I'm freaking having a meltdown. Cosine of x plus 4, wrong number, 4, plus 2. Let's go ahead and take a look at this. Now we do the same thing. We go back 1, 2, 3, 4, and then we go up 1, 2, right? That's our little spot. And just like we did before, we draw our little lines. Boom, this right here is our spot that we start at. We're going up 4, back 2, because that's it on the inside, that's on the outside. And then we just go up, let's go ahead and start our cosine. Then it goes there, and then there, and it does its little cosine stuff. But for the purposes of this, you don't really need to have accurate drawings of it. You just need to know what the shifts are. And mathematically speaking, it's pretty easy to tell, regardless of if my drawings are accurate or not. You know that it's up or back 4 and up 2. So let's go ahead and also talk about the amplitude. So that stuff, that's your vertical shift and your horizontal shift. Same thing as with your square root of x, same stuff. Now with the amplitude, if I just have a graph of y equals, let's just take sine of x, for example, because it's easier for me to draw. So if we have y equals sine of x, right, and we have, remember, stuff on the inside affects the x-axis, stuff on the outside affects the y-axis. I don't know exactly how Cooper taught you the waves and stuff and what amplitude is, but amplitude is essentially if you have a thing, right? So amplitude is the space from, if this is your 0 line, it's from your rest to your crest. So it's basically half of this whole length right here, right? This whole darn length. It's basically half of that. And I just messed up everything. I had to erase it. So if I have a sine wave, right? A standard sine wave, even though this is badly drawn, a standard sine wave goes at points pi over 2, pi, 3 pi over 2, and 2 pi. And the 2 pi needs to be right here. Let's just pretend that it was 2 pi. Okay, so this is the cosine, right? This is the cosine wave. And these points on the standard cosine wave, if we make it into a real graph, are going to be 1 and -1. So what's the amplitude? Well, from rest to crest, how much is it? It's 1. If you have sine of x, cosine of x, it's going to be 1. It's this distance right here from the top to the bottom. If you have a standard sine or cosine, it's going to be 1. It's pretty simple. That's just how it is. And so if we multiply it by something, if the standard height is 1, let's say we have y equals 3 sine of x, right? So let's take a look at our, I'm going to have to draw it smaller. Let's take a look at our standard sine wave where we have 1, -1. We're going to have pi over 2, pi, 3 pi over 2, and then 2 pi. Okay. Then we're going to go the loop-de-loop. Oh my god, I messed it up so bad. Jesus Christ. I'm awful at this. Okay. Pi over 2, pi, 3 pi over 2, 2 pi. Okay, so we start at the bottom, right? Go up, and then down, and then we meet there, and then we go like this. Okay, sine wave. Beautiful. Okay, so this is our sine wave, right? Goes from 1 to 1. And I might actually want to start using my eraser a little bit. And my these little magnets. I'll just leave them. You can sit in the corner. So this is our standard sine wave. So if we have 3 sine of x, this is affecting the y-axis because it's on the outside by 3 times. So we're affecting the y-axis by 3 times. So what do you think the amplitude is going to be? If it's normally 1, now it's going to be 3. Each one gets multiplied by 3. So the y is getting stretched by 3 because if it's on the outside, it's getting stretched by 3. If it's on the inside, it's getting stretched, or if it's on the outside, it's getting stretched on the y. If it's on the inside, it's getting stretched on the x. So let's go ahead and say that it's 3. So then we just say that it's the same thing, but it goes to 3. And it goes even bigger, and yeah, so it's even bigger than our old one, which was just this. Whatever, that one's wrong. I don't care. Whatever, it's bigger. I'm not the greatest at drawing sine waves. Okay, sorry about that. God. Okay, so yeah, this one is clearly bigger. It's being multiplied by 3. So now, what if it's on the inside? So let's say that y equals sine of 3x, right? And if y equals sine of, no, I'm going to make this easy. Y equals sine of 2x, right? Okay, and I am 99% sure, it's been a while, but I'm like 99% sure that it, hold on, y equals sine 2x. What does that mean? Graph for sine of 2x. Wait, what's the graph of sine of x? I'm having to Google this shit real quick. Graph of sine of 2x. I don't want this. Oh, shit. All of this shit is in fucking. What does he do? Okay, I just want the fucking answer, dude. X equals pi. So your period is increasing, right? Okay, I'm like 99% sure. Yeah, because your period is the number of times that it repeats. So you're dividing a period by 2. X equals pi over 2. Oh my god, okay, I understand it now. Okay, took me a second. Okay, so if you have sine equals 2x, right? Sine equals 2x. It applies to the inside of it, but it's the opposite, right? So if I just have my normal sine wave right here, right? This is going to be a little different because if it's on the inside, it affects the period. And that is something that is unique to sine and cosine. You're not going to see that in your other graphs. All this other stuff you've seen before. I'm just applying it to sine and cosine. So let's say sine of 2x, right? You got the 1, you got the negative 1. It's not really that important because we're not going to change it. But what is important is that we have... Actually, I'm going to make this big. I'm going to make this real big. And I'm going to actually see if I can use a different color for each of them. So... I'm going to say we got 1, negative 1, then we got pi over 2, we got pi, we got 3 pi over 2, and we got 2 pi, okay? So let me go ahead and draw in black marker the graph of sine. Oh god, my thing is really off, but I don't care. Okay, so let me just draw the graph of sine, right? We go up, and then we go down, then we go there, and then we go back there, okay? So that is a normal graph. It's in black. Now, let me draw sine of 2x. Since it's on the inside, we're not stretching our y, we're stretching our x, right? And it's the opposite. So if we add on the inside, we subtract. So if we multiply, then therefore we must divide. So if we are doing division, right, we're dividing the x-axis by 2. So that means we're squeezing it in. We're not stretching it, we're squeezing it, right? Because we're not making it longer, we're not increasing it, we're dividing, so we're making it smaller by a factor of 2. So we can essentially just divide our period by 2, because the period is defined as the time when it repeats. So in this case, the period is 2 pi, because one complete sine, when it gets from the same point to the same point again, is 2 pi, right? So we're just going to shrink that. So I'm going to show you visually what that looks like if we shrink it by 2. So if we shrink it by 2, this is our graph, right? You see how it's the same graph, but it's shrunken down. It gets quicker. In this is the same graph as this, but it's shrunk, right? So we're shrinking it down. And if I were to say sine of x over 2, we were dividing it by 2, or 1/2 x, I'll write it as 1/2 x, we would stretch it out because we're doing the opposite. We're dividing, therefore we multiply by 2. So we would have a big old sine wave like this, right? It'd be big because we're stretching it out. And if we were to do 8x, we would have a really tiny sine wave that does a lot in a little bit. So hopefully you're understanding conceptually how this stuff works. So let's go ahead and bring it all together with the first problem on the worksheet. Number 1, 3 cosine of x plus 2. So your period's going to be in terms of pi, but you just look at what's on the inside and do that. So number 1, y equals 3 cosine of x plus 2, okay? So we're looking for our amplitude, our vertical shift, our horizontal shift, and our period. That's what we're looking for. Those are our answers, right? So since we're looking for those, let's go ahead and I'll visualize what this graph would look like. But you can just solve this mathematically. So let's see. There's nothing in the middle. So horizontal shift, there's nothing happening to it. If we were to draw this, and we have our graph, right? And we're looking at, okay, there's nothing horizontally. There's nothing happening inside with our x. So our horizontal shift is just going to be 0. It's not going anywhere. Plus 2, that means we're going to go up 1, 2, because it's on the outside, therefore it affects our y. So we're going to be going up 2. And we're being multiplied by 3, which means our graph is going to be 3 times larger on the y. And again, amplitude is a measurement of the rest to the crest. It's this little guy right here, this height right there, and that's going to be increased by 3 times. So without even looking, let's say if it starts there, we're going to be plussing it by, it's going to be 3 bigger, right? So even without drawing this, if I were to draw this graph, I know that if this is the normal sine wave, right, then this is going to be my new one because it's bigger, you know? It's got a bigger top, okay? So since it's going to be 3 times bigger, what's the normal amplitude of a sine wave? Well, it's always going to be 1, or sine or cosine, the amplitude is always 1. So 3 times 1, well, that's going to be 3. Nothing else is going to happen. So if we go ahead and draw this, right? I'm not even going to mark the pi things because we're not using them right now. 1, 2, 3, 4. No, let's just pretend that those guys are there. Then we can say that this hits there. This goes up by 3, so this is 5. And then -1. So this is going up 3, down 3. Goes up 3, down 3. There we go. It's really bad, but that's the wave. If this was more wavy, this is how it would be. So, but without even drawing it, we know what is the vertical shift. Well, we're going up 2, so the vertical shift is 2. What's our amplitude? Well, we're multiplying it. Amplitude is y-axis vertically. It's going to be 3 times bigger, or taller, right? So it's going to be 3 times taller, so we know our amplitude is just 3, because it's 3 times 1, which is the normal thing for cosine. Our horizontal shift, there's nothing happening in here. It's just an x, so that's going to be 0. And the period, just remember, it's always going to be 2 pi on a normal thing, if nothing is happening to it, because that's the vertical amount that it goes, unless you're affecting the x-axis, in which the period is being shrunken. So your period is just going to be 2 pi. And for most of these problems, your period is going to be 2 pi, but not always. So that's the answer to the first problem, without even making a graph. And you don't have to make a graph. You can just look at the stuff. So let's go ahead and move on, me trying to preserve as much as I can, to the second problem. And let me take a look at which problems seem like they're the hardest. There's that one. There's only like 5 of them. Okay, so problem number 2. Y equals negative sine of 8x minus 1. So the sign is going to be negative. However, I am 99% sure that amplitude is not going to be negative, like at all. So, I think we can just ignore that. I don't know, I'm not in Algebra 2 right now, I don't know. But negative sign would just be, instead of going like this, it would go like this, where it would go down first. You know, instead of up first, right, it would go down first. That's positive, that's negative. But that doesn't affect the amplitude, because it's still, like, the amplitude is just, I don't think it's a negative, but, oh well, we'll see. We'll see if you get the question wrong or not. So the amplitude, there's nothing happening to the sign, so it's just being negative. So therefore the amplitude is just going to be, 1, right? What's happening to the horizontal, what's happening to the vertical shift? What's happened to the y-axis? Well, it's going to be -1. So your vertical shift is -1. What's happened to the horizontal? Is there a number plus or minus with that x? Nope, nothing having to do with that. That's going to be 0. And then your period. Now, that 8x is affecting your period. Because remember, if you have something multiplied by the x, it's affecting the x-axis. That's this way. If it's something on the outside, it's affecting the y-axis. That's the amplitude. If it's on the x-axis, it's this way. And your period is a measure of this way. So it's squishing your sign, right? It's squishing it. So 8x. This is dividing by 8, right? Because remember, if it's on the inside, you do the opposite. So what's your normal period? You should have probably said 2 pi. This is dividing by 8. 2 pi divided by 8. As simple as that. Which simplifies to pi over 4. Boom, you're done. Pi over 4, easy. And if I were to draw this graph, I would do all that, but you don't need to do that. I already showed you conceptually how it looks on a graph. So yeah, I'm pretty sure that's all you need to do for that. For the next one, number 3, and I erased everything. Y equals -3 cosine of 1/4 x. Very important that 1/4 is inside of the x. We're looking for amplitude, vertical shift, horizontal shift, and period. Okay? So for this one, right? You're going to have a -3. Now, the negative cosine means that instead of starting off at the top and going down there, it's going to start off at the bottom and going down there, okay? But I don't believe it affects the amplitude. Don't quote me on that. I don't think the amplitude can be negative. I'm like 99% sure it can't be. But I don't know. Maybe it is. I'm not sure. But in any case, your amplitude is going to be 3 because it's 3 times, it's affecting the y-axis. So if this is your normal cosine, if this is your normal cosine, right, then this is going to be your other cosine because it's taller, it's bigger, right? So it's going to be taller, it's stretched on the y, so that means your amplitude is going to be 3. Is there any plus or minus on the outside? No. It's going to be 0. Anything on the inside? Nope, going to be 0. Now, this is an interesting case. So this is 1/4 x, right? And because it's 1/4 x, we do the opposite. Do not think that this is 1/4 of 2 pi, okay? We're doing the opposite of what's on the inside. So if this is dividing by 4, what are we going to do? Well, we're going to multiply by 4, right? So the x is being expanded by 4, right? What's the standard period for every sine or cosine wave? 2 pi. What's 2 pi times 4? 2 times 8? That's going to be 8 pi. Period's 8 pi. Okay? Not too bad. Next problem. Wait, I already did 3. Okay. 4. Number 4. Okay. Y equals 1/3 sine of x plus pi over 2. Okay? Beater. Okay. So, with this one, we got our amplitude, our vertical shift. I really need to quit erasing this. Okay. Boop, 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 boop. Okay. So, we got this, right? Y equals 1/3 sine of x plus pi over half. Okay. Now, this is probably very scary because what is this? What is pi over 2? You're not multiplying by it. There's a pi. There's not supposed to be a pi in the why is there a pi? Why is there a pi? Well, I'm going to tell you why there's a pi. So, let's not touch that right now. Vertical shift. What's happening on the outside? Zilch. Nada. Nothing. Nothing on the outside. Period. Is the x being multiplied by anything? Nope. Nothing. It's just an x. Just sitting there. Amplitude. What's it being multiplied by? 1/3. That means you're going to be tiny. If this is the normal sine wave, then this is going to be your sine wave. It's going to be teeny tiny. Look at that. It's so tiny. So that means the amplitude's going to be teeny tiny small. How much smaller? 1/3. Amplitude's 1/3. Easy peasy. Now, horizontal shift. This is where this comes in. So, let me visualize this. If you have a graph that is sine, right? Sine starts here, and then it goes up, and it goes up, and down, and back to where it started, right? And we can mark these guys as being 1, -1. We can mark all these wonderful points as pi over 2, pi, 3 pi over 2, and 2 pi. Okay? So what does adding pi over 2 mean? Or actually subtracting pi over 2, because you always reverse it, always reverse what's on the inside, and you reverse it. So what's this doing? Well, we're just like if we had x plus 4, just like how this problem would move the graph 4 over to the left because we're subtracting 4 because we're doing the opposite, this will just move the graph over pi over 2. How big is pi over 2? Pi over 2 is about that big. See there? Pi over 2 by half. Luckily, all these graphs are in terms of pi over 2. Pi over 2, pi, 3 pi over 2, 2 pi. They're all in terms of it. So all you just do is just whoop. You just kind of move it on over. And you say, whoop, we're just going to push it on back. If that's where this was, then this is now going to be here, right? And then we're just going to move it on back. And we're pushing it back. So we're just kind of boop, pushing that graph back. It's the same thing, but we're just moving it on over back. So what is the horizontal shift? Remember, it's minus pi over 2. Because it's on the inside, that's their x-axis. That is horizontal. Okay, time to pull a big brain and carefully erase time and leap on past it. Number 5, very last one. This is like 30 minutes, but I hope there's 6. I don't thought there were 5. Okay. Well, hopefully you'll have a deep in-depth understanding of this after this. Or maybe I just wasted 30 minutes for nothing. Hopefully you understand this after this. So y equals cosine of x minus pi minus 2. Look at this, right? Easy stuff, easy stuff. What is cosine being multiplied by? What's the number in front of the y? There is no number there. Amplitude 0, nothing, none, zilch, nada. X, 3x, 5x, 1/4 x, 2/4 x, nope, nothing. It's just an x. There's nothing else doing with it. Just x. Period, 0, done. Now, vertical and horizontal shift. Vertical is on the outside. It's dealing with the y. Minus 2. Your graph is going down 2. Vertical shift, minus 2. Easy. Horizontal shift, same thing as before. However, be sure to do the opposite. Instead of minus pi, we're adding pi. We're going this way. So we're just, instead of pushing it back pi over 2, we're pushing it forward pi. Plus pi. Easy peasy. Same thing. Final problem. Is this one a toughie or is this an easy one? Oh, this isn't that bad. This is super easy. In fact, I think this is so easy that I think that you can do it on your own. Right? I think that you can do this on your own. Just remember that the x is in there. 5 sine of x plus 3. You know what to look for. You know which numbers mean that. Go ahead and do that problem, okay?